Hello, this is Ms. DB. In this video we are going to review how to divide polynomials. This will take a little longer than adding and subtracting and multiplying polynomials. It's a little bit more of a lengthy process. The first thing I want to review is how to do long division with numbers, with integers. So there's an example here, but I'm going to go through my own example. I'm just going to make one up. I'm going to say like 752 divided by 5. So to divide, the first thing we do is we look at the number in the hundreds place and you think, how many 5s will go into 7? So the answer is 1. So 1 times 5, then you multiply this, and you put that number 1 above the 7, and then you multiply these two numbers back to each other. So 1 times 5 is 5, and you write that right under the 7. Now this step is important. You then subtract the 5 from the 7, and you get 2. Now we repeat this process after bringing down the next number. So we bring down the number in the tens place, that's a 5, so you put that right after the 2. So we have 25. And then you think to yourself, how many 5s would be in 25? Or in other words, 25 divided by 5, and there would be 5 of them. And then you multiply back again. 5 times 5 is 25. And then don't forget to subtract, and you get 0 for this one. And then you bring down the number in the ones place, so that's 2. Now there are no 5s in 2. You don't really need this 0 here, are there? There are 0 5s within the 2. And then I guess we multiply back, but 0 times 5 is 0, and then we subtract. 2 minus 0 is 2. That 2 is a remainder. So we have 150, remainder 2, but we don't write remainder 2. We did when you were very first learning this. But after a while, then you said, okay, that 2 will go over the number that we are dividing by, and that is the 5. So our total answer would be 150 and 2/5. All right, let's look at doing this with polynomials. There's an example here, so you can go back and look at that, but I'm going to jump right to one of the problems on your worksheet. Some of them are set up already for division, like number 1 and number 3, and in some of them you need to write this part in the front, and then this will be what you're dividing by. Let's do number 2. So the x plus 1 goes here, and then inside of the division sign goes the other polynomial that you are dividing by. This worksheet is easier to do if you can do it on a piece of paper or using a pen tool on a notebook computer. It's harder to type it. So do it on paper, take a picture, and submit the picture for 1 through 8. After 1 through 8, they're easier to type. We do synthetic division, which we'll get into. Alright, so what we're going to do when we do this is we think about, we're really focusing on the x here, and we'll worry about the plus 1 when we multiply back. So you're thinking to yourself, 2x to the third, how many x's are in there? So in other words, if you were to divide this by x, you'd get the x squared and there'd still be the 2. So I'm going to write 2x squared right here because that's what I get. But I have to worry about the plus 1 when I multiply back. So now I'm going to multiply 2x squared times x plus 1, and that's going to get written underneath. So 2x squared times x would be 2x to the third, and then 2x squared times 1 is 2x squared. So I just took, I divided the 2x to the third, I just divided it by x rather than by x plus 1, and I got 2x squared, and I wrote that on top, and then I multiplied back. Now remember, the next step when we were doing our problem with integers is to divide. We change this, not to divide, to subtract. We change this to subtracting. So that means that I have to subtract both of these terms from the 2x cubed plus 5x squared that's above it. So we have 5x squared minus 2x squared, that's 3x squared. And then we have 2x to the third minus 2x to the third, well, that part's 0. So we're just left with 3x squared, and then we bring down the next term, minus 7x. And then we repeat this process. We think to ourselves, we have 3x squared minus 7x, and we're dividing by an x. So just look at the first parts. We're dividing by x plus 1, but we're just going to look at the 3x squared divided by x. and that would be 3x. So that's what gets written on top next. Okay, now we multiply back. So 3x, I'm going to do this off. These are just my notes off to the side, this scribble stuff. So now I'm going to multiply 3x times x plus 1. That's 3x squared plus 3x. So that gets written underneath here, 3x squared plus 3x. Now we have to subtract. So I have to subtract this term and this term. So 3x squared minus 3x squared, that's 0. Now we have negative 7x minus 3x, that's minus 10x. So now we have to take negative 10x, divide by x. Well, that one's a little easier to do in our head, that's just negative 10. And then we multiply back one more time. So negative 10 times x plus 1. That one's a little easier to do in our head as well. Oh, I forgot to bring down the minus 6. Minus 6. Okay, so we have negative 10x minus 10. Negative 10x minus 10. And then we have to subtract. So this becomes a positive. When we subtract a negative, we get a positive. And this becomes a positive. Let me move this down a little bit. I just want to, maybe I can erase it. I just wanted to erase that line that was blocking my, come on, it won't let me erase. There we go, okay. And I'll erase this notes here too, so I have a little more room. Okay, so now we're going to add negative 6 plus 10 is a 4, and then the negative 10x plus 10x, that's 0. So I'm left with just a 4. At that point, that's like our remainder, but we don't write remainder 4. We take the 4 and we put it above what we are dividing by, x plus 1. And that is the solution. So the whole answer would be 2x squared plus 3x minus 10 plus 4 over x plus 1. Alright, let's look at one that's already set up like number 4. X minus 5 goes into, or we have 3x squared minus 5x minus 50 divided by x minus 5. So again, we focus on the first term, the x, and we're thinking to ourselves 3x squared divided by x. What would be left if I pulled an x out of that? Well, we would be left with 3x because one of the x's would be pulled out. Then you multiply back. And when you multiply back, you have to multiply it by the x minus 5, the whole thing that's in the front. So 3x times x is 3x squared. And then 3x times negative 5 would be minus 15x. Then we have to subtract. So we change the sign of both when we subtract. Now we combine the 3x squared minus 5x with the negative 3x squared plus 15x. So you can see it's always going to be the first terms are going to cancel. 3x squared minus 3x squared is 0. And then we have negative 5x plus 15x. That's a positive 10x. And then you bring down your next term. This one's a little easier. It's because it's shorter. And then you think to yourself, now we have the problem 10x minus 50 divided by x minus 5. So you think to yourself, if I had 10x and I was pulling the x out, what would you be left with? Well, you'd just be left with the 10. So then we multiply back. 10 times x minus 5. So 10 times x is 10x. 10 times negative 5 would be minus 50. And then we have to change the sign of both of them. And then we combine. So 10x minus 10x is 0. Negative 50 plus 50 is also 0. There's no remainder in this one. This one just equals 3x plus 10. That means if we were to multiply 3x plus 10 times x minus 5, we would get 3x squared minus 5x minus 50. And you can FOIL it to check. But our answer for this problem is the dividing problem, so it would just be 3x plus 10. So every once in a while you'll get one without a remainder. That means that those two polynomials multiplied by each other would equal the starting part. Alright, so we have, I'm just double checking that we've done all of our steps. We've done 2 of those. I'm just going to give you a hint on number 8. When you do number 8, there's a term missing. When you do long division or when you do synthetic division, you have to have all of the terms have to be there. So in number 8, there's a 3x to the third plus 9x squared. There's no x term. So when you do your long division, you have to add a 0 where the x squared term should show up. Okay, so we'd have 3x to the third plus 9x squared. That's all good, but there's no x term. You don't have to write 0x, you can just write 0. And then the next one after that would be the minus 14. So when you start dividing, there's going to be a placeholder there. So when you bring that next term down, you'll have a 0 for that. We'll just do it a little ways. So 3x to the third, and we're thinking if I pull the x out, if I divide by x, well, I would just reduce that by 1x. So I'd have x squared instead of x to the third. And then you multiply back. So 3x squared times x would be 3x to the third. 3x squared times 3 is 9x squared. So when I subtract, that means change the sign of both of these, I don't have anything. I have 0. 9x squared minus 9x squared is 0. 3x to the third minus 3x to the third is 0. And I bring my next term down, that's also 0. So the next term here is going to be 0. 0. This one's very strange. And 0 times x plus 3 is 0. So basically you're just going to bring down your minus 14 here. And that will be your remainder. I'm out of room to write that. So our answer for this one would be 3x squared minus 14 over x plus 3. That one ended up being a weird looking problem. All right, next up is determining all the real number solutions to the following polynomials using the rational root theorem. The rational root theorem says, I want to get an example here, that if you take all of the factors of the constant at the end, all the factors of 5, and divide it by all the factors of the first coefficient, the leading coefficient, that will give you all your possible options for roots, for solutions. Now sometimes there's a lot, sometimes there's only a few. In this case there's a lot, because the factors of 5 are 1 and 5, that's not that many. But the factors of 12, there's a lot of factors of 12. 1, 2, 3, 4, 6, and 12. And you have to take the plus or the negative of all of them. So there's many factors for this one that would be possible roots. Once you have those listed, then you're going to divide them or write them as fractions. So it is all of these top numbers divided by all of the bottom numbers. So 1 over 1, well that's just 1. You should simplify these. And then you'd have 1 over 2. That one can't be simplified. Then you'd have 1 over 3. Then you'd have 1 over 4. Then you'd have 1 over 6. Then you'd have 1 over 12. And these are all plus or minus, because the negatives work too. And then you move to the 5, and you do 5 over 1, which is just 5. 5 over 2, 5 halves. 5 over 3, 5 over 4, 5 over 6, and 5 over 12. So you can see they listed them all out. And then check if there's any duplicates, cross them off. There's not in this case. And if there's any that can be simplified, do that, simplify them. Actually, you should simplify first and then cross off. Yours don't have as many factors when you do 9, 10, and 11. Let's look at number 10. The constant at the end is 6, so you have to list all the factors of 6. 1, 2, 3, and 6. And then the first one is the same thing, 1, 2, 3, and 6. So then you're going to write these all as pairs of fractions. So 1 over 1, I've got that one down. And then I went 2 over 1. And then 3 over 1. And then 6 over 1. And then I'm going to move to the 2. This 2 here. And I have to do 2 over 1. But 2 over 1, wait, I did 2, I have to, yeah, 2 over 1 was already taken care of. So 2 over 2, that's 1, that's the same as this. So once you write them all, here, I'm going to write them in a little bit more room. Okay, so I did all of these over 1. 1 over 1, 2 over 1, 3 over 1, 6 over 1. Now I'm going to write them all over 2. I think I started doing the same thing twice. So 1 over 2, 2 over 2, 3 over 2, and 6 over 2. Then I have to do them all over 3. 1 over 3, 2 over 3, 3 out of 3, 6 out of 3. And then I do them all over 6. This 6. So 1 over 6, 2 over 6, 3 over 6, and 6 over 6. Now if I simplify these fractions, there's going to be duplicates. Let's simplify them. So 1 over 1 simplifies to 1. 2 over 1 simplifies to 2. 3 over 1 simplifies to 3. 6 over 1 simplifies to 6. 1 over 2, that's as simple as it can get. 2 over 2 simplifies to 1. I already have 1. I don't need to write it again. 3 over 2. 6 over 2 simplifies to 3. I already have 3. I don't need to write that again. Okay, 1 over 3. 2 over 3. 3 over 3 simplifies to 1. I already have that. I don't need to write it again. 6 over 3 simplifies to 2. I already have that. I don't need to write it again. 1 over 6. 2 over 6 simplifies to 1/3. Do I have that? Yep, I have that. 3 over 6 simplifies to 1/2. Do I have that? Yep, I have that. And 6 over 6 simplifies to 1, and I already have that. So the list gets smaller once you simplify your fractions and cross off any duplicates. Don't forget that this is plus or minus, so all of these could be the positive numbers, they could all be the negative numbers. For each one it's plus or minus, but you can just put a plus or minus in front. These are all the possible roots for this polynomial. These would all be possible solutions, which means you wouldn't get a remainder when you divided by it. That doesn't mean they're all roots, but any real root will be in this list. And you would start trying the easier ones first, and then start trying the fractions if you didn't find them in the integer answers. Alright, now we're going to move on to synthetic division. Synthetic division is another way of doing division that is a little bit less hard to write it out. So to do synthetic division, there's a good example here with all of the steps. What we're going to do is start by taking the opposite sign of your divisor right here. So we have x plus 2, so we're going to write a minus 2 here. So use the opposite sign. And then I should show you how to do this typing because it's not so bad. Okay, so you start with the negative 2, and then I'm going to put a vertical line showing kind of a box around it. And then after that you're going to put just the coefficients of your polynomial that you're dividing. Put a 0 for any term that's missing. So we have 1x cubed because there's no number there, a 6x squared, 7x, and then plus 10. So we write those coefficients down. 1, put a couple spaces, 6, put a couple spaces, 7, put a couple spaces, 10. Then skip a line or 2 and then draw a horizontal line underneath that. Alright, next we're going to start doing our work. So what you do for the first one is you just drop down the 1 and you put it down here under the 1, under your line, 1. Now we multiply back. We take our 1 times negative 2, 1 times negative 2 is negative 2, and you put that number under the next term, so under the 6. I'm down a little bit too far. So under the 6 you put your negative 2, the multiplication. Then you add together 6 plus negative 2, or you combine 6 minus 2, and we get 4. So after the 1 I'll put the 4 now, a couple spaces. I'm trying to line that up so you can see that 6 minus 2 is 4. Then we multiply back. Whoops, I went too far. 4 times negative 2 is negative 8. That's going to go under the 7, negative 8. 7 plus negative 8 is negative 1, and that will go next, right underneath that. Then we multiply back. Negative 1 times negative 2. Negative times negative is positive, so we would get a positive 2 here, and we put that under the 10. And then we combine. They're both plus, so you'd add those. 10 plus 2 is 12. That's it. Now, what do we do with this? Those are the coefficients of the polynomial that we get when we would divide these. you have to reduce the exponent on your leading term by 1. So we started with x cubed. We're going to have x squared as our answer. So this will be equal to, use the coefficient that you got first, which was a 1 x squared. Then we'll reduce that by 1, so the next one will be x, and we have a 4 for the coefficient, so 4x. Then we have a 1, and there's no more x's to use. X squared, x. We ran out of x's, so we just write that's our constant, minus 1. And then what's the 12? The 12 is the remainder. So you have to take 12 divided by our divisor that we started with, x plus 2. So this one can be written by typing, or you might find it easier to do it by hand on paper, and that's fine too. And that's our answer then. This is what we get for an answer when we do the synthetic division. In number 13, and in several other of these, they're missing a term, and you have to add your 0 term. This one is in one of the Khan Academy videos that's in your folder, so let me look at number 16. Sometimes these numbers get really big too. In 16, we have 3x to the 5th plus 4x to the 3rd. We're missing the x to the 4th term. And then we're missing the x squared term too. So we're going to have a couple zeros in this one that we'll have to add. So we start with putting the opposite of our sign of our divisor. So instead of minus 1, we put a plus 1. And then we write our coefficients, adding any zeros for missing terms. So 3x to the 5th plus 0x to the 4th plus 4x to the 3rd plus 0x squared minus 1x, because there's no number in front of it, so that's a 1, and then minus 2 for our constant. Then put a few spaces, a few lines down, and then put a line to show that here's where we're going to be working. I probably needed less lines there. Okay, then the first one that you do is you bring down the 3 straight down. So the 3 will come straight down here. And then we take our 3 and we multiply it by our 1. And that will go under the 0 term. 3 times 1 is 3. Then we combine 0 plus 3 is 3. 3 times 1, we multiply back again. 3 times 1 is 3, so that goes under the 4 term. Then we combine 4 plus 3, and that is 7. Then we combine, or multiply back, 7 times 1 is 7. And you keep going, adding and multiplying, until you get all done. And then remember that I'm not done. I'll let you finish it. But then these are the coefficients of the polynomial that you would get when you divide, and you have to start your polynomial with 1 degree less than your original did. So 3x to the 4th plus 3x to the 3rd plus, and then you would do 7x squared plus 7x plus the not constant, and then your last one will be the remainder. Number 18 says, which of the division problems above generate no remainder? What does that mean? I don't know if you'll get any in the synthetic division that had no remainder, but we did have one when we did long division that had no remainder. Which one was that? Number 4 had no remainder. And what that means is that your result, your dividend, or your quotient times your divisor will equal what you started with. So it means that you had like a perfect division here, that both of those are factors of the original problem. Did this one have a remainder? Yeah, this one had a remainder too. But if you don't have a remainder, then it means you could multiply them back together and you would get the original problem. Yeah, I don't know if any of the synthetic divisions you'll get that though. All right, so the last part here, you're going to, this part's pretty easy. You're just going to use synthetic division to evaluate at a given value. So you would just take the number. So in this, look at the example first. We have x to the 3rd minus 4x squared plus 3x minus 5, and we want to evaluate at x equals 4. Now you could plug 4 in and find what 4 cubed minus 4x, or 4 times 4 squared plus 3 times 4 minus, you could find it that way too, but using synthetic division is pretty fast. You put your 4 here just like we did before, don't change the sign, and then you put your coefficients, and then you do the synthetic division, and the remainder is what you would get if you plugged 4 in for all of the x's. So like for 20, there's a 0 term here for x, so you might want to write plus 0x so you don't forget. I've lost my pen. Here it is. Okay, so they want us to evaluate it for -3, so you leave the -3, and then you put your coefficients here, 1x cubed plus 3x squared plus 0x plus 4. So you bring the 1 down. 1 times -3 is -3. 3 plus -3 is 0. 0 times -3 is 0. 0. 0 times -3 is 0. The remainder is 4. That means that all of this, that p at -3 would equal 4. In other words, if I put -3 in here, and here, and here, I would get 4 for an answer. And then that is how you, it's faster actually than plugging it back in. And then one more section at the end where you're going to find all the zeros given 1 0. So they tell us that 6 works. So they did the rational root theorem where they found all of the possible factors of 72 divided by 1. There's a lot of factors of 72. And they're telling us that 6 is one of them. So what you do is you do synthetic or long division of 6 and write the resulting polynomial. So the resulting polynomial, this would be, remember we reduced the exponent by 1, so you'd have 1x squared minus 2x minus 12, and it should be 0 because they told us that it was a root. This sometimes can be factored. So if you can factor it, do so. That would be easier. But in this case, there are no factors of -12 that when you add them, you get -2. This one's in your textbook. So then they used the quadratic formula to find the other factors. There's 2 of them, 1 plus square root of 13 and 1 minus the square root of 13. So these are the other roots. However, if you end up with something that can be factored, like what if you ended up with x squared plus 5x plus 4? That can be factored into x plus 4 times x plus 1. That means that your other roots would be -4 and -1. You know, set these equal to 0 each part, and then solve for 0. Solve for x, I mean. So that way, if you can factor it, it's easier. And I think both of yours you'll be able to factor. So your first step is to use the 0 that they give us to do synthetic division. So they tell us that that is a factor. A lot of 2's. And then use the polynomial that you get when you multiply this. 2 times 1 is 2. Yep, so that's 0. So this resulting polynomial would be 2x squared plus 4x plus 2. You can factor out a common denominator of that factor. Let's do that. That'd be x squared. Oh, yeah, it looks like that's a squared, but it's not. Plus 2x plus 1. And then see if you can factor this. Because if you can factor it, it's easier to find the roots than using quadratic formula. If you can factor this, then take each of your factors, whatever you get, equal to 0, and solve it, and you'll be able to get your other 2 roots, just like we did in the quadratic chapter. Alright, this is kind of a long video. If you made it to the end, congratulations, and have a wonderful